learning. Then you should be able to know the difference between software development and machine learning stroke deep learning. Then you should be able to understand the general idea about building a model, and you should identify the common terms that is used in machine learning and their meanings. So these are the learning objectives. So when we finish this particular chapter or this module, we'll go back to this objective again and see how many people are able to do all of these things. So at the moment, I don't know, maybe some of you might have a bit of background in AI. So maybe a few of you will be able to do all of these things. Or I don't know, maybe all of you already have the idea, but we are still going to go over it. So we'll talk about the deep learning framework, because in this particular for this particular course, we are going to be using the PyTorch deep learning framework. So actually, there are different. And when yesterday when we started the class, can somebody remind me the programming language I said we are going to be using? So why did I say we will be using Python? Yes. So because it's open source. What another reason again? Yes. So that's very important. So I said Python is the language of AI. So it's better we speak the same language. So that's why we are using Python. So under Python, there are different deep learning framework that you can use to create different models, deep learning models you want to create. So the framework we are going to be using in this course is PyTorch. But I want you to understand that it is not only PyTorch that is the only framework for deep learning. We have other deep learning frameworks. So we have other deep learning frameworks like TensorFlow, Keras, and Cognitive Toolkit, and Scikit-learn, and there are many, Theano. So these are some of the deep learning frameworks that are available. But for this particular class, we'll just restrict our attention to the PyTorch framework. So why are we using PyTorch? PyTorch is an open source deep learning framework. So all the other ones I've mentioned previously, they are also open source. So, but PyTorch was developed by Facebook AI, so now known as Meta AI, and it offers a lot of capability. So it can be used to solve many kind of problems, including optimization problem. So after this even in this module, we'll start linear regression model. So you can use it to develop models as simple as linear regression and as complex as computer vision and natural language processing tasks. So that's what PyTorch can do. And it has lots of libraries, lots of APIs, lots of tools that it uses to achieve its function. For instance, in the linear regression problem, it uses an algorithm like gradient descent to find the optimal solution for the weight. So we'll be talking more on that. And it also has a module called the AutoGrad module, which it uses for the gradient descent algorithm. So all the other deep learning framework like TensorFlow, Keras, Scikit-learn, Theano, all of them, they also can also solve optimization problem, and they also have outstanding capabilities. But the ones we'll be using is PyTorch. The Scikit-learn is really very popular. Who has heard of Scikit-learn before? Who has used it? scikit-learn, so Keras, TensorFlow. So if you're already into AI, so you would have heard of this before. But in this class, we'll be using the PyTorch. So what are the things PyTorch can do? So it can do computer vision tasks like object detection, medical image analysis, image recognition, video classification and detection. So like all of these things probably is just like a library you will call. So once you want to do any of these tasks, you're just going to call a library or a function, and when you import that function into your Python code, then doing all of these tasks would not be a problem. Then it also has application in natural language processing. So remember yesterday I told you that we have 4 modules, and the last module is natural language processing. So we'll be able to do things like text classification, summarization, sentiment analysis, and question answering engine. Then it can do graph neural network, so and temporal graph neural network. So this and this, they are like, we're not going to be using all of this. We're not going to be considering these applications, but you just to know the capabilities of PyTorch. So it can do all of this. Also reinforcement learning. I will come back to reinforcement learning later when I talk about the types of machine learning. All of this, we are not going to be using it in this particular course because they are out of scope for what we want to do. The only thing that is within our scope is just these two: computer vision and natural language processing. So the others, they are beyond our scope. But I would encourage you that even though it's not, we are not going to be doing them, no, we are not going to be using them for this particular course. So it's like you can make it like a challenge for yourself. So maybe like a final year project. You can try to just look at all of these things, then how you can apply machine learning or AI into it. So for PyTorch, you have a lot of libraries that you can import, and it will do a wide range of, there are a wide range of applications that is possible within the PyTorch ecosystem. So we also have the other ones like scikit-learn, TensorFlow. They can also do the same thing. So it's just that we just want to limit ourselves in this course to the PyTorch. So apart from PyTorch, we are also going to be making use of Hugging Face. So Hugging Face is a large open source community and it is a central hub for models in Python programming, especially in the area of natural language processing. So PyTorch has a huge library that's if one is doing natural language processing tasks, it's going to be really very easy. So alongside PyTorch, we are also going to be using Hugging Face, because the Hugging Face, they also make use of PyTorch also in their community. So we'll be making use of this PyTorch and Hugging Face. You'll be making use of it in this particular course. So I now want to go to the types of machine learning we have. So remember yesterday, I told you that you have data science. Like I drew a diagram. So you have data science. Within data science is artificial intelligence. Within artificial intelligence is machine learning, and within machine learning is deep learning. So data science is like a broad field, and the reason why data science was involved is because the bedrock of artificial intelligence is data. Because without data, you data was like the whole field. So within that you have AI. So we said that AI is about giving machines the cognitive ability, like reasoning, problem solving. That's AI. Then machine learning is a subset of AI, and it involves using data to make predictions. That's machine learning. You want to make future predictions with data or based on information on data. That's machine learning. And deep learning is like using like complex neural network in order to make that prediction. That's deep learning. So under machine learning, we have three categories under machine learning. We have the supervised learning, we have the unsupervised learning, and we have the reinforcement learning. So those are the three subcategories under machine learning. And what is supervised learning? Supervised learning is learning from labeled data. Unsupervised learning is learning, the data is not labeled, but given the data, you are trying to find relationship or hidden patterns within the data. Then what's reinforcement learning? Reinforcement learning is giving machines the ability to make decisions through trial and error. I want you to note that supervised and unsupervised learning, they deal with data. You have to use data. But reinforcement learning, on the other hand, does not involve the use of data. There is no like a data set that you would have to train in a reinforcement learning for a reinforcement learning task. So let's explain supervised learning. So you have supervised learning. So supervised learning, like I said, is when you train a model using labeled data. So an example is like teaching a child when you are teaching like a toddler, maybe objects in a particular space. So you are giving the toddler the information, and you are also giving the toddler the name of that particular object. So for instance, you can say that, okay, this is a fan. You point to the object and say that, okay, a fan. So this supervised learning, because you've shown the child the data, like look at it, and you've told the child the answer. So fan. So this object is a fan. So that's supervised learning. So when you tell the child the answer, so that maybe later or the following day, you now point to this, and what is this? The toddler should be able to remember based on what you taught him that this is a fan. So that's supervised learning. You give the computer data and you label it that, okay, you give the computer different images of a fan, and you train a model so that when it looks at another object, it knows that, okay, based on the data it has been trained on, that this is actually the object. So supervised learning is giving the answer to the particular problem and training a model so that in the future it will be able to predict that, okay, this is the right answer for that particular question. So that's supervised learning. Supervised learning can be divided into two: classification and regression. So classification is predicting labels that are in a category or in a class. You are predicting discrete things. Like for instance, if you want to differentiate between a zebra or a horse, there are two things, zebra and horse. So that's classification. If you want to determine if an email is spam or no spam, that's classification. It doesn't have to be two, it can be three. It can be three things. It doesn't necessarily have to be two. That's why I didn't put binary. So it's just discrete. You are differentiating this from this from this. So that's classification. Then regression predicts labels that are numeric. So in the sense that maybe given a piece of input, what is the price of a particular house? So I made mention of an example yesterday. So I said that maybe you have some inputs, maybe the location of the house, the size of the house in square footage, where the house is located, maybe the house is in a GRA or is in a rural area. So those are the inputs. So based on it, what is the price of that particular house? So that's regression. It's not discrete that, okay, this, it has to be that this or this. The output is numeric and is not, is continuous. So you did 322 with me in 300 level. Classification is like you are in the discrete time domain. So you are in the discrete time domain. But regression is what? Continuous time domain. So the regression is like continuous numeric value, but classification is discrete. So it's just based on a category or a class. So we'll now look at some, based on my explanation. Let's do the following examples. For instance, the question is to tell me if it is classification problem or if it's a regression kind of machine learning. So the first one, an app to identify the plant type from an image. So why is it classification? Okay. So the second one, an e-commerce site predicting the prices of their products. Regression. Okay. An e-commerce site recommending products based on other customers' purchase similarities. Okay. A car dealership is scoring their customers on a long-term value into 1, 2, 3, or 4. Okay. A medical research company is predicting drug dosages for patients. That regression was really low. Who thinks this classification? Okay, so the last one. A design software that removes noise from visual data to improve picture quality. Classification or regression? Why is it regression? Because it's not it's continuous. So it's regression. Who thinks it's classification? Who thinks it's classification? Who thinks it's regression? So what I want you to know about, so you're talking about machine learning. So there are 3 types: supervised, unsupervised, and reinforcement learning. When I define machine learning, I said that machine learning is used to make prediction about future data. So you are predicting, but you have some information. So you use data is used to train it. Then after the model has been trained, you can use it to make prediction. So this first one, identifying the type of plant type from an image. You are predicting, right? This one too, predicting. This one, recommending. You are trying to predict to make the customer buy. Predicting too, scoring. You are predicting that maybe it's a 1, 2, or 3, or 4. This one too is predicting. This last example, is it even an AI problem? Not. Is it predicting anything? So is it machine learning at all? Is it? Huh? So this last one, is it the machine learning problem? Yeah? So, in my own opinion, I don't think it's a machine learning problem. So, like, I'm the odd one out because machine learning is to predict about future, is to make prediction. So that's what machine learning is all about. Like, he was saying that this is, if to say this an image is noisy and another image is not noisy. So if the question was to determine if an image is noisy or not, then I would agree that it's a machine learning problem. But this one is saying it's removing. Machine learning is predicting. It cannot, apart from prediction, it cannot do anything. It can't remove. I don't know. That's just my own opinion, and I may be wrong, but I don't actually think that this is a machine. It's an AI problem. Yes, AI, but machine learning, I don't know. I don't think so. So that's just my own opinion. So let's go to unsupervised learning. So she was trying to say that okay, it's a machine learning problem, but unsupervised learning. So let's try to look at what unsupervised learning is all about. In unsupervised learning, the data is not labeled. So, like for instance, you are training a model, but you are just leaving it open. You are just giving the data and just say that just look for some similarities or patterns in in the data and just collect the similarities together. So you are not actually telling the computer the answer. In supervised learning, you will show the computer that this is the answer, this is the data, this is the answer. So that when it finds another data that is similar, then it will be like, okay, I've seen this before, so this is it. But in unsupervised learning, you are not labeling the data, you are not giving the computer the answer. You just give it different kind of data and just find the similarity. What is the similarity? What's the connecting link between that in that particular data? So one example is giving a child like blocks of toys and just tell the child that, okay, just sort it out. Just sort out the toys. So the child can either sort it by size or it can sort the toys by color. So in a machine learning sense, one application is maybe you give different news stories. One is entertainment, one is political, one is on health, one is on lifestyle, different stories, and you expect the computer to group similar stories together, similar news stories together. So that's unsupervised learning. You are not giving the computer the answer, but you are just trying to tell the computer to just find similarity, to look for patterns or similarity in the data and split the data into groups. So that is unsupervised learning. So let's do some examples. You would tell me if it's supervised or unsupervised. So the first one, you ask a child to sort toys, and they can do it based on any characteristics in life. Yes, unsupervised, because you just give the child data and just find the similarity, just sort it any way you want. So that's unsupervised learning. But in this second example, you ask a child to sort toys into stuffed trucks and building materials. So, yes, supervised, because the answer is there. The answer is there. You told the child what to do, to sort it into the categories you want it sorted out. Then under supervised, is it classification or regression? So it's classification. So we talk about the third type of machine learning is reinforcement learning. So what's reinforcement learning? Reinforcement learning is not, it does, like I said, it doesn't have to do with data. So reinforcement learning is the only kind of AI that doesn't, okay, I wanted to say that doesn't use data, but actually it doesn't use data, but it uses experience. It uses experience, but it doesn't use data. So it learns from continuous experience rather than labels or historical patterns of data. So what I made an error, I said that it doesn't learn from data, but it learns from continuous experience. And you know, continuous experience, when it first starts, it has no experience, there's no data. But with experience, it gathers some amount of data. So I was actually wrong, actually. So it uses data, but when it first of all, like a certain point, there's no data information available. So, and the learning comes through interaction. So one real life example I will give of reinforcement learning is also called learning trial by error learning. So one instance I will give is, for instance, a child now, maybe you have a child, maybe a 7-year-old or an 8-year-old, like maybe he's in a school, and maybe he comes the first position in his class. So when he brings his report card, you see that okay, he came first. You gave him a present, you gave him a reward. So probably the next time, maybe I don't know what happened, he's now like the last, and you just give him a punishment. Go and sweep the whole house for 1 week. You really want to sweep the whole house. That's a punishment. So with that, the child is learning that okay, when I came first, okay, I was given a present, and when I came last, I was given a punishment. So he's learning that okay, I need to maybe next time, in the previous time, let me try and become the first, because I didn't really like it when I had to sweep the whole house for 1 week. So that's reinforcement learning. It's through experience. So it's majorly used in robotics. Like we put the robots in a space. So when the robot moves in the required direction, there's a reward that is given. And when it moves in, maybe it's collides with an obstacle, there is a punishment. So that's like learning from experience. And all of this, reward, punishment, action. So in reinforcement learning, for every action the system takes, a reward is given. And the system goal is to maximize the accumulated reward. So this word action is an equation. So you specify the action by an equation. This reward is also a function, is an equation. Even the punishment is also a mathematical function. So that is reinforcement learning. Reinforcement learning is learning through trial and error. And when it first of all starts, there is no data, but it learns from continuous experience. So these are the three kinds of machine learning we have: the supervised, unsupervised, and reinforcement learning. But unfortunately, I don't know, unsupervised and reinforcement learning, they are beyond our scope for this particular course. So they are beyond our scope. Our focus for this particular course is supervised learning. So even though it's beyond our scope, it doesn't mean that maybe if you want to do a final year project and you want to make use of unsupervised, you can still make use of it. But we are just limited in our scope to supervised learning. So before we round up for today, I want to go into the difference between software development and machine learning or deep learning. So one thing you should note is that machine learning is different from traditional programming. It's different from software and traditional programming. So like for instance now, if you want to write a function, you want to program to convert Celsius into Fahrenheit, all you just need is a line of code. So you know the equation. You already know the equation that was to convert Celsius into Fahrenheit. So you just write the equation in form of the code, and the code will do it for you. So that's traditional programming or software development. So that's you give data, then you have the rules. The rules in this case is the equation, and data is like the value you want to convert. Then you write the computer program, and the computer program will give you your output. But machine learning is different from software development, and it's different from traditional programming. So for The reason why it's different is because in machine learning makes prediction, and machine learning also it can also detect. So for instance, now, is it possible to write a computer program that will identify that, okay, this is a person? Is there any equation that you can put that when you write it, it will now determine that, okay, this is a person or this is an animal? There's no equation available. So in machine learning, it's the other way around. There's no equation, because in software development, you have the equation, you have the rule that if you put in the input, you will get the output. But in machine learning, there's no kind of equation available. So this is what happens in machine learning. You give it data, you give the computer data, and you will tell the computer the answer, the output. Remember when I was talking about supervised learning, that you give the data and you tell the child that this is this image. Then this kind of the machine learning model, this is kind of the machine learning model. So you develop a machine learning model, then within the machine learning model, I don't know, subconscious is going to generate the rules. So that's the difference between traditional programming and machine learning. In traditional programming, you have the data and you have the rules, which are the equation. Then it will produce the output. But in machine learning, you have the data and you have the output. You will show the machine the output. Then it's going to develop the rules to identify that particular object or that particular problem. And that is kind of the way one of the reasons why we said that machine learning is under AI. You know, when I defined artificial intelligence, I said like cognitive functions, giving cognitive functions to machines, like reasoning, problem solving. If you look at it, that is the way we human beings, that's the way we are when we are learning. It's like maybe to know that this is a fan or this is a chair. Is there any kind of equation that we are saying that, okay, in our brain, okay, if I put this equation and this equation, then I will know that this is a fan, or I will know that this is a clock. The way our brains are wired, we are not using equations. It's just that we just learn it. So when, for instance, when you are teaching a child now, okay, that this is a laptop, okay, and the child is just going to automatically remember that this is a laptop. So that's the way our brain, that's how we learn. We don't learn through equations, and there's no any equation you can write, no program you can write that will be able to help you differentiate maybe a horse from a cat or a cat from a dog. So these are the things machine learning can do. So we learn by examples. So even now that I'm teaching, some of you already have an idea of what machine learning is. Some don't have an idea. But those people that don't have an idea, and they're just listening to me for the first time, you are learning about machine learning. What I'm saying, how are you able to actually, maybe when you are trying to even think about it, how are you able to remember? Is it equation you are using to remember? Is it rules you are using to remember? So it's by example, like I'm just talking, I'm giving examples, and I'm giving you the data, and I'm giving you the outputs, and your brain, I don't know, magically is just able to develop the rules, just magically. So that's the way we human beings, that's how we learn. We learn by examples. It's not like a kind of equation in our brain that is making us to remember what we are taught. We just there's a kind of neural network in our brain that is just helping us to remember what since we were born, so what we have been taught so far. So this is so that's the difference between machine learning and traditional programming. So we call traditional programming, we call it software 1.0. So in that software 1.0 is traditional programming. You give it data, you give it rules, which are the equations, then it would generate the output. But in the case of machine learning, it's another way round. So it's the other way round. So you give it the data and you tell it the answer, then it's going to generate the rules for you. So those are the differences between machine. So we call this one software. Traditional programming is software 1.0. Then machine learning, we call it software 2.0. So so that's that. So the next topic is linear regression. So we're not going to be, we'll do that in the next class. So we'll do that in the next class. So you're going to stop here for today. So before we stop, I want to ask you. So these are the learning objectives. We've not completed the module, but these are the learning objectives. So in all the objectives, which one can you do now? Okay, 1 and 2. So all of you can tell me the difference between supervised and unsupervised machine learning. And you can tell me the difference between software development and machine learning. So what's the difference between, can somebody just tell me the difference between software development and machine learning? You all said you can do it. Okay.
Software development is give you machines like the machine get the desired output, get what you want. But it's not really possible in AI because the data you feed will change over time. So each will create rules and just give examples. So it's kind of training and it's get better. So that's the main difference in the world. Okay, somebody from the back. So those of that back, you don't know the difference between software development and machine learning. Okay.
Okay. All right. So for the next part of the class, you'll be able to, I think, be able to do these two things. So the attendance.